Hello, it's Mr. Primer here, and in this video we're going to be learning about how to draw ray diagrams for convex mirrors. So convex mirrors are the opposite of concave. Any ray that's coming in parallel to the principal axis will be reflected outward. So all the rays that come in will diverge instead of a concave where they'll converge. So in this case we don't have the focal point on this side because any rays that come in are going to be diverted away, reflected away. So instead, the focal point, we're going to actually put it on this side. And even though light's not actually going to go here, it's going to help us figure out where this image will go. So first thing we're going to do is draw a line that's parallel to the principal axis. So we draw parallel to the principal axis. It's coming in this way. And we're not going to go through the focal point now because the light's not going to go through the mirror. Instead, it's going to be reflected away, but it's going to be reflected in line with the focal point. So you line up your ruler with the focal point, go to this point right here where it hits the mirror, and then start the ray back this way. And then we can draw an arrow here to show that it's bouncing off this way. Okay, so now let's draw one more line, and this time we're going to draw a line from the point of the object that's in line with the focal point. So in line with the object, and in line with the focal point. So start at the object, and this line is in line with the focal point. We're not going to go past the mirror because the light's not going to go past the mirror. Instead, it's going to be reflected now, and because it's in line with the focal point, it's going to bounce back parallel to the principal axis. So now we can draw a ray that's going parallel to the principal axis. Here we go. So here are two rays now. And as you can see, they are diverging. So if we kind of picture our eye over here, kind of, our eye and our brain can tell that these rays are from the same origin, or they should be, but they're diverging. So our brain's going to kind of extrapolate this information backwards. So we use the reflected rays, and we draw virtual rays behind the mirror that are in line with the reflected rays. So one is this way, and you only use the reflected rays. You don't use the incident rays. So I don't use this line right here because this is an incident ray. I just use the rays that are going outward towards the eye. And so here's the other reflected ray. So I will draw it in line with this mirror, with this ray. And this is the one that's also in line with the focal point. So go down here like this. And as you can see, they converge right here. And so if this is point A of the object, then this will be point A of the image. And I'll draw that in right now. So here it is. Here is the image. And so the nice thing about learning convex mirrors is that this same situation will happen no matter where the object is. It will look a little bit different, but it will always be smaller than the object, and it'll always be closer than the object, and it'll always be upright, and it will always be virtual. So let's just write that down. So we're looking at the properties. So this is the acronym SALT. So for size, S, so it's smaller. For attitude, it is upright. For location, it is closer to the mirror. And for type, it is a virtual image because it is located behind the mirror, and we have the virtual rays there to represent that. So the actual rays of light are not converging, so it's virtual. So that's how you draw a ray diagram for a convex mirror, and I hope you're having a great day.